Alright, in this tutorial we're going to have a little revision of vector pathways or vector journeys. So I'm going to start with this question. In the diagram, A to B equals 2 D to C. Express each of the following displacement in terms of vectors V and W. So before we start doing them, I just want to see if there's anything I can fill in using this information. So A to B is 2 DC. Alright, so if that's V, and we know that that's double that, we actually know that this one here is 2V. So if you can mark that in, then that's good, because then we've got an extra place. We can get almost anywhere now using these. So I'm going to do each one. Try and always write which journey you're doing, so C, or just always write it. So C to D. C to D, we're going to go against the direction of the vector V, so it's going to be minus V. And then that's you. Done that, you've got to the pathway you wanted. C to A for the next one. So C down to A, we can only go along, we can't go this way because we don't know what that vector there is. So we have to go minus V minus W. The reason it's the minus is because we're going against the direction of the arrow. Right, next one we've got A to B. So A to B, we've worked out in this, so that's useful. A to B is 2V from the information we marked in over here. C to B. C to B, even though there's this line, we don't know what that vector is, so we're going to have to go all the way around. So minus V minus W plus 2V. And then if you can tidy it up at all, you must, because it's simplifying. You can see that we've got 2V and minus V, so that actually just leaves us with 1V. So V minus W is what C to B becomes. And finally in this question, B to D. So B to D, we have to go along the way we know, so minus 2V plus W. So we might want to write the W first because that's the positive one, minus 2V. You could have written minus 2V plus W, that's absolutely no problem. All right, that's our first question. Just looking over some of the more basic things with vector journeys. Next one I'm going to look at is this one here. Then I'm going to do two past paper questions. So in the diagram, M is the midpoint of BC. And we can see that they've been marked as the same length. Express each of the following displacement in terms of vectors P and Q. So we're just going to do the same thing. So CB, we've got C to B, so we have to go along the journeys we know. We've got minus P plus Q, minus P plus Q. Again, I would probably write that out as Q minus P. I like to have the positive first, but you would not be incorrect if you left it the first way. B, we've got B to C, so other way, minus Q plus P. Again, I would prefer to write that as P minus Q, the other way around. Then we've got B to M, so we've got a little bit more to think about this time. So B to M, we know because this is halfway, that's half of the journey from B to C. So BM is half of the journey from B to C. So we're going to write that first. Now we know what B to C is. We know that it's P minus Q. So we can change that to half P minus Q. You can leave it like that, or you can multiply out the bracket, a half P minus a half Q. And then finally, we have A to M. So A to M, we could go two different ways. We could go from here to here, which is probably a good one to know because we know what B to M is. We just found that in the last one. So yeah, I'm going to do from A to M is going to be Q plus B to M. Q plus the B to M. We know what B to M is. So it's Q plus a half P minus a half Q. Q minus a half Q leaves you with just positive a half Q. So we end up with a half P plus a half Q. And that's our journey there. Right, I'm going to look at 2 past paper questions now, and then we'll leave it there for vector journeys and pathways. So this one here says, the diagram shows a square-based pyramid, P, Q, R, S, T. Express RP, so R to P, in terms of F, G, and H. Right, so for this one, we've got a square at the bottom here. Now you can label vectors the same thing as long as they are the same length and they're going in the same direction. So we know that F is going to be the same length as this back one. If we put this arrow the same way, this way, then we can also label that F. So if we know we can do that for that, you also know you can do it for G. So the only reason it's the ones that are opposite, they're going in the same direction. That's what makes vectors the same. So we can also label that one G. Right, I just wanted to point out, because a lot of times people look at this R to P and think that that would be the same as this one here. But they're not actually going in the same direction. This one's going up in a totally different direction from H here. So you can't just use H. That's totally different. T to P is different from R to P. So now that I've marked in the other ones that I did know, this should be fairly straightforward. So R to P, you're writing what you're doing. R to P, if we can get to T, then we can get up to P. And we've got that here by doing minus G minus F plus H. Minus G plus F plus H. So just following that again, we've gone against the direction of G, so it's minus G, going against the direction of F, minus F plus H. You could have also done it the other way, minus F minus G plus H. And so that's you. You could, if you, oh sorry, I've written plus F. You could, if you wanted to, flip that around so that you had the positive one first, H minus F minus G. Doesn't matter, you could leave it like that, minus G minus F plus H. All right, I'm going to look at one more now. So in the diagram, OA, BC, DE is a regular hexagon with centre M. Vectors A and B, I'm just going to underline these, are represented by AB and OC respectively, so that journey. Express AB in terms of A and B. Right, so I'm just going to get some more paper because there's not much space on this one. So A to B, we're going from A to B. Obviously we can't go this way right now because we've not labelled anything, but you can see that you can go minus A plus B. So that's minus A plus B, or B minus A. So minus A plus B. Next one, express OC in terms of A and B. O to C. So right now, there's no pathway, including the vectors that we know. So sort of like what we did before, we're going to have to try and mark in ones that we know would be the same length and mark in the direction so that they've got the same. So because this is a regular hexagon, I know that here, I could mark in this one here, and that would be the same length as A, because we've got this regular hexagon there. From the middle to the side is going to be the same as this one. You can sort of see that through that shape as well. So I could mark that in as A. Now you might have started spotting other bits that you can mark in, but if you've got this shape down here like that, we could do exactly the same on the other side. That would also be A. You could also mark in that similar diagonal, just to match exactly what you've got down there with B. And now we have a lot more pathways to think of. We can probably find one now from O to C. So I can see here that if I did B, so I'm going to just do B minus A minus A. I'm just going to write it out fully, this, and we'll simplify it then. Minus A plus another B, we're going to get from O up to C. B minus A plus B, which works out as 2B minus 2A. And that's your journey from O to C. And actually you can have a little look at some vector pathways questions now.